Now that you've visualized your data from the bottom and the back as both positive and negative versions, it's time to figure out how the data from the bottom and the back interacts. So normally I would suggest starting with the first interaction that happens inside of this top front corner of the cube. That means on the bottom it will be the foremost piece of data, this little rectangle here, and this rectangle at the top right side of the right rear face of the cube. The first step is to project out that data, just like we did with the full set of data from the bottom and the back. But here you want to take this in bite-sized pieces, because if you try to extrude everything and then figure out interactions, you'll be pulling your hair out. So let's start by pulling this up from the bottom, this out from the back, and then we'll talk about how those interact in the cube and how to construct that. Since this data and this data both occupy a face or touch a face of the cube, figuring out the interaction of this data is relatively simple, because we can see that this bottom edge corresponds, comes across on this face. These two lines come up on this face, so we can trust anything that's on faces and only what's on faces. So we know that these 2 points are where an interaction starts, and on the top we can also see that this corresponds with that, so that is going to occupy the top face of this volume from the back. So just to show what that interaction looks like, I will do that in orange. So that orange volume is the intersection, or it could be the intersection. It is the interaction of the bottom and the back data. Note that I drew it wireframe, because just like you saw in the additive and subtractive versions, this could become a solid or it could become a removal, in which case those might be the edges of a removal. So let's look at what the Boolean interactions of those two shapes might look like, or the variations of the Booleans. The first Boolean interaction is union, which, if we're using kind of the MasterCard Venn diagram idea, a union of these shapes is like that. In the Boolean, the interaction disappears inside this face because those are on the same plane. So we only draw a line when there's a change in plane. This is stepped in a little bit, so that comes across. So that's what the union looks like. The next would be subtraction. So subtraction could look A minus B, or B minus A. Let's try the first. For intersection, we're only going to see the piece that's left over, or the piece where both of the sets of data overlap. So that's the basic Booleans, but you can also come up with variations on those. I think I demonstrated in class what would happen if basically these come and as soon as they touch each other, they are annihilated or they stop their extrusion. Conversely, you could say only where they touch do they become manifest. So this comes out invisibly, and then maybe this only shows up where it interacts with the bottom data. Call that true love. I only become whole after I meet you. And there are other endless possibilities here that you can explore with the Booleans. Just try to make them logical or relatively logical and consistently applied. Once you get into multiple interactions, there could be other possibilities such as switching on and off, etc.